we sent warning that are shiny for sample size calculation using these three parameters. Open the software, that is a program that is there in the, see here. So you have to copy this folder, file open. Put the folder here. Choose this one, shiny R. Sample size. Am I going fast? I'll wait. Good, okay.
Why shiny that?
Where is the better?
There is no package called shiny dye.
So you open them. This opens up. Maybe I'll wait for it.
It is there only, sir. You just have to click that install shiny.
Morning it was there. Do you get the screen? So this is data is already input, 80% versus 70%. Alpha error and beta. Calculate, click calculate. It says that the hazard ratio is 1.6 and number of events required is this much and the total sample size per arm is 296. What I said was that it does not go by 70% or 80%. Supposing if I assume that the difference should be much higher, in the new intervention it should be the 85%. Supposing I put the 85%, which is not very bad as compared to 80%. And I calculate sample size. So you need 125 in each. Reduces the number drastically. So therefore, it is not just one go calculation. You have to put various scenarios and see whether that will be accepted by any reader. It should not be very obvious to to put a big difference to reduce your sample size. ARB is supposed to look at it. Massaging the number by putting a lot of values, big difference in it. Any question? So the time is fixed. They say probability of survival is it at 5 years or 10 years or 2 years? That kind of thing has to be discussed. Okay. Then I'll go into survival probabilities. You have unequal number of unequal distributions between this one. Sometimes you may not get controls more, cases more, and so on. This is HR with sensory, HR without sensory, medium. So this is, say, for example, HR with sensory, HR without sensory. Let me say the hazard ratio is 0.2 and this is 0.4. This is 50% less as compared to the other one. This is lambda, that is hazard rate in the treatment group, has to be smaller. Hazard should be smaller here, and here it should be much higher. So you can see. And significance level. So let's say usually two-sided test is taken, calculate the sample size. So sample size per group is 48 units.
Without sensing, does it mean the previous paper is not any censoring the captain may have?
Usually we don't. Sometimes let's say, for example, the question is if the data has 40% 50% censoring, is it reliable? The question is why censoring is so much there. So therefore, that is something. If they have given the data into it, you just put that correction censor. Let us look at that. What happens if I choose censoring here? So is it asking censoring concept lambda? This is asking about time and not the sensor. Something. So chart without censoring. So this has to be corrected. We'll correct it and send it to you. We have to give you what percentage of censoring that I am expecting. And so we'll check that one. Usually, the conservatively, the journals, top level journals insist on conservative. Two-sided hypothesis. You know why two-sided hypothesis? It's very unlikely to reject the null hypothesis when you take two-sided hypothesis. Unless you are very specific that I have a one-sided treatment is going to benefit the patients, very strong about that, then it is one-sided hypothesis. The cutoff value which we fixed for one-sided is 1.64. Because the cutoff value which we fixed for two-sided is 1.96. The T statistics or Z statistics, 1.96 is very difficult to get. Therefore, you are less likely to reject the null hypothesis in the two-sided. Therefore, it is always better you put the sample size calculation two-sided. You understand this concept? The normal distribution, the 5% area, the two-sided hypothesis, 5% leftover is 2.5% here, 2.5%. So when you look at the Z value or T value at 2.5%, is 1.96, almost 2. But if you put all the error in one side, that is 5% here, the cutoff value is 1.64, smaller as compared to 2. So you are looking for a T or Z statistics which is greater than 1.64 when you do a test, T test or whatever. Easy to get a T test or Z test which is greater than 1.64. Very unlikely to get 2. So therefore, less likely to reject the null hypothesis. Yes. So that is why the journals, I think, can't remember, used to tell us some of the top level journals insist on their policies to so, irrespective of your whatever decision. And so we'll check on the censoring part. Yes, I wanted to introduce Rojan. Rojan, can you please come here? Rojan is a graduate. See, bias is leading today. See, biostatistics students from St. Thomas College. Come. St. Thomas College, Pala. He did his internship with us for 3 months in clinical epidemiology. So we observed him, and he has got the talents for IT. So he was very able to do innovative projects during the 3 months. So I requested him whether he can work on this project. Shiny. So he started. He was gave him only 2 months. So he was able to do a lot of stuff. So he's in Kerala now. So this is, we'll correct this part, and maybe we are planning to send you the revised version of the plans. So please share it with your colleagues, whatever you do, and it will be useful. And some of these aspects are not available in the state places. Current event analysis. These things are not available in the state. I mean, of course, we have. We should know how to do it. That is all I have in sample size calculation. Median time is, say, for example, this is 4 months and 6 months. This is for group 2, 6 months, and 5% level of significance and 80% power. And so calculate the sample size. See here, it says 190. The sample size per group is 96. So this is include actual and follow-up time. So for example, actual follow-up time is, accrual time is, for example, recruitment period is, for example, we don't take 12 months, maybe 6 months or whatever. And follow-up time is 2 years, 24 months. A small difference, 99 per arm. So we have not given you the references. So we'll try to link all these references so that we can quote that references. NMaster has that facility. When you do the sample size calculation, you can always take that reference and put it in the paper. So this is available in the department. You can buy it from the department. So therefore, as you see here, there are 3 concepts. One is mostly we deal with the survival probabilities given a time period. Another one is hazard rate. And if you see any Cox proportional hazard model, you find a variable of interest in your study. Take that hazard and decide your sample size, which is much easier to do. And the other one is that AFT model, accelerated failure time model, compare the time period, which is rarely done. But still, you can use this one based on the survival graph. You can look at the time period and use it to compare to decide your sample size. Any questions? Yes. Yeah.
What is the expected proportion or the advantage in that? And what is the expected reduction? Is it initial and genetic? What is the actual time of the recruitment time? What is the filtration? But can I write this number also 190 number? That's what can happen is once my study is done, I can see what number of events in my one arm as compared to the other. But this talks about the total number of yeah, right, this number also in the proposal.
You run into trouble. Somebody will pick up the small thing and say that they have not reached so many events. Why giving the data? We understand. Don't give too much of information. You understand what I'm saying? It says how many events that you should get. If I review the paper, you said a priori, you have said you should have got 191 events, but in your study you got only 150 or something like that, which is a minor thing. And so they'll ask, I mean, you need to clarify why and so on and so forth. I will not give that. I mean, you are from industry, so you have to be very specific. And after the people to get that kind of thing. Academic institutions, you are not that accurate to say I'll have to get so many events. The events are very important. Yesterday you had about recurrent event analysis. This is the Anderson Gin model and so on and so forth. Where the number of events are important and the time period. Maybe in that area, domain that you might be interested in. So whether you do frailty model, which we are going to see tomorrow today, and clustering model, make that calculation very simple based on the survival probability. So don't go into the details of number of events as much as possible. Anyway, we'll discuss it. It's something which will come up in the discussion. Okay. So I'll stop.